All right, good morning. This is your Stat Sensei, and this is scenario four of the take-home quiz. This is 2004 question six. So yes, this is an investigative task, which means it's a little bit longer and a little bit more challenging. So a pharmaceutical company has developed a new drug to reduce cholesterol. A regulatory agency will recommend the new drug for use if there is convincing evidence that the mean reduction in cholesterol level after 1 month of use is more than 120. So all right, so basically, we'd say if it's the reduction is more than 120 or more than 20, um, because that would be greater than the mean reduction for the currently most widely used drug. The pharmaceutical company collected data by giving the new drug to a random sample of 50 people, the population of people with high cholesterol. The reduction in cholesterol level after 1 month, so that means we have a sample size of 50, used was recorded for each of the sample, resulting in a sample mean uh, uh, reduction and standard deviation of 24. So our X bar is 24, and our sample standard deviation is 15. The regulatory agency decides to use an interval estimate. So, okay, we're going to use a confidence interval for the population mean reduction in cholesterol level for the new drug. Provide this 95% confidence interval. Be sure to interpret. All right. So working with a 95% confidence interval. So we're doing a one sample T interval for means. Always need to name the test. If we were writing the hypothesis, I just think it's usually um, um, great mu equals 20. Now, I have something that's different. I wrote greater than here, but I wrote not equal to here. Why? The reason why is this is the confidence interval, and all confidence intervals are two-tailed tests. So this is 0.95, and the area over here is 0.025, and the area here is 0.025. All right, so this is going to be a confidence interval. And all confidence intervals are two-tailed tests. That's going to be important, and that might help us out later on. That's one of the reasons I like to write down what are null and alternative. Might want to cross it out if you're concerned that you made a mistake, but nonetheless, that's why I write it down for myself. Mu equals the true population mean reduction in cholesterol level for the new drug. Yes. Conditions. We have a random sample. We have a random sample size 50, and that was given. Don't do this right here. Then the n is less than 10%. 50 divided by 0.1. It's reasonable to assume that there are more than 500 people with high cholesterol. Yeah, I'm pretty sure of that. The next thing, normality. Well, in this case, our sample size is 50 is greater than 30. The distribution of means is approximately normal by central limit theorem. Awesome. We write our formula, x bar plus or minus t star s divided by square root of n. We know it's a t we know we're working with a t because we're working with the standard deviation of the sample, which was 15. So in this case, we have 24 plus or minus. We'll come back to t star in just a moment. Sample mean of 15, square root of 50. So the question is, how do I get the 2.0096? Well, we're doing a 95% confidence interval. So second vars, inverse t, parenthesis 1 minus 0.95, close parenthesis, divided by 2, degrees of freedom. Because this is a one sample t, 50 minus 1, and we end up getting 2.0096. All right. So there that is. That's my work shown. Cross this part out. And I'm going to go ahead and run this interval, stat test, drop down to t interval, which is number 8. And we had a sample mean of 15. Excuse me, a sample mean of 24. Sample standard deviation of 15. And a sample size of 50. And when we go to run a 0.95, we get our interval estimate, which is 19.737 and 28.263. So there's our interval. So we're 95% confident the true population mean reduction in cholesterol level for the new drug lies within this interval. Now, one thing I notice about this is 20 is contained in the interval. All right. So because 20 is contained in the interval, I'm not going to be very excited because I needed 20 not to be contained in the interval. I needed all positive values greater than 20. I get that. This part was not so always wanted to make sure that we write this down to make sure that we take care of things. So in repeated sampling, we expected our method would capture the true population mean reduction in cholesterol for the new drug 95% of the time. Okay, so we've taken care of part A. Part B, because the 95 interval concludes 20, they just told you better have 20. Regulatory agency is not impressed. They're not convinced that the new drug is better than a current bestseller. The pharmaceutical company tested the following hypothesis: mu equals 20 versus mu is greater than 20, where mu represents the population mean reduction in cholesterol level for the new drug. And they got a T statistic of 1.89. So here's what they did. They sat there and go, okay, this is the claim of 20. And we got 24. They did an upper tail test and they ended up getting a p-value of 0.033. That's their X bar. This is their mean. All right. Because the p-value was less than 0.05, the company believes that there is convincing evidence that the mean reduction in cholesterol for the new drug is more than 20. Explain why the confidence interval and the hypothesis test led to different conclusions. Well, hope I can fit all this on the screen. No, I can't. I'll have to fold the paper just a bit. Give me just a second. All right. The hypothesis test was two-tailed with a rejection area of 0.05, 0.025 on the northern tail, all right, on the two tails. Here we have a rejection area of 0.05. So here, alpha is all in one tail, alpha is split between two tails, and that's our differential. So the confidence interval in part A was a two-tailed test with an alpha level of 0.05. Because it was a two-tailed test, the rejection in any one tail was 0.025. In contrast, the test that the company ran was a one-tail upper tail test with the entire alpha, 0.05 alpha, all in the upper tail. Because the confidence interval had a larger rejection region of 0.05 than that of the regulatory agents, 0.25, the company was able to reject a null. As a result of the different size rejection region, the company and regulatory agents had different conclusions, even though the alpha levels were equivalent. All right, very long explanation, but you needed to come up with something similar to that. All right. So, still not finished. Part C. The company would like to determine a value L that would allow them to make the following statement. We are 95% confident the true population mean reduction in cholesterol level is greater than L. A statement of this form is called a one-sided confidence interval. So they're telling us, oh, we want a one-sided confidence interval that they can be found using the formula. All right. We've never ever seen this before. Haven't introduced this in class. Not part of the question. Typical what will we do? All right. So this has the same form as the lower endpoint of the confidence interval in part A, but requires a different critical value. What should be used as T star? All right, so here's the thing. T star is based on 0.05. So the second vars, inverse T. Change our area, instead of doing that, 0.05. Degrees of freedom is still the same. And now we get a T star value of 1.6765. All right. So am I missing something here? Hold on. I'm going to have to pause this for a moment. May have left something out on my typing. All right. So I want to continue on with B, even though I paused and started with C, but I'll come back to that in a second. For the test to have been equivalent, the regulatory agency would had to utilize a 90% confidence interval, because that would have given us alpha level of 0.05 in each tail. However, if the agency had run a significance level of 0.025, it would have been, or the company had run a 0.025 significance level, that would have been equivalent. Didn't have to have all that information, but there it is. Okay, I don't know what happened, but when I got to part C, I left off, whatever I typed up disappeared. So I don't have part C and part D typed up, so I'm gonna have to work these out here. So the company would like to determine a value of L that will let them make the following statement. We are 95% confident. Well, we have this formula, as I said, that we didn't know. Well, that means I need to calculate T star. Well, T star is either based on 95% or 0.05. It really wouldn't matter. Second bars, inverse T. And we use 0.05. Degrees of freedom is 50 minus 1. And we're going to get negative 1.67. And the reason I say it doesn't matter, if I did a 0.95, I get the positive value. So it really wouldn't matter. I always want to do these using a positive value. It just makes my life easier. So in this case, it says compute the value of L. All right. Well, L equals X bar, which was, we had a sample mean of 24, minus T star, we just said was 1.6765. We have a sample standard deviation of 15 in the square root of our sample size of 50. So if I do that, 24 minus 1.6765, and I times 15 divided by the square root of 50, 50 raised to the half power, I end up getting a lower bound of 20.44. All right, so my lower bound of my confidence interval, instead of being, because up here we had a lower bound of the confidence interval being 19.737. Now I have a lower bound being 20.44. Hey, that's great. Why? Because that is above the claim of 20. All right. So lower bound is on that ended up being 20. So 20.44. So that's good. We just said L equals the 20.44, and that takes care of part C. If the regulatory agent had used the one-sided confidence interval part C rather than a confidence interval part B, would it have reached a different conclusion? And the answer is yes. Yes, it would have reached a different conclusion. So yes, the conclusion would be different because 20.44 is greater than 20. All right. So why did this happen? This happened because we are basically using a 90% confidence interval. All right. So that takes care of that. I don't think I did the best job on that, but I apologize for not having that all typed out for us. All right. I hope you'll stay tuned for the next one. This is your stat sensei, Mr. Spensei.